Hi. Today we are going to talk about HPC, which is high performance computing as an industry, and how we at Wild One cater to different companies from this industry. So today I have my colleague Rahul with me, who has previously worked extensively in HPC, be it in benchmarks, be it in selecting right hardware, which is suitable for HPC clusters, HPC individual machines. So let's go through some question and answers with Rahul today. So Rahul, when we say we serve customers across cloud, HPC and AI industries, or even edge for that matter, let's talk today about HPC. Can you help us just talk about how different HPC is from traditional cloud computing?
Sure. Typically, in most cases, cloud computing is virtual, flexible, and on the go.
Okay.
And HPC, on the other hand, is dedicated. And what I mean by dedicated is people actually are working on HPC projects or HPC workloads will have dedicated hardware assigned. While in cloud computing, the hardware may change depending on availability, feasibility, money, all of those things come into picture.
Understood. So just as an example, who all use HPC?
So HPC typically is done by researchers, scientists, engineers. For example, weather forecasting is a very good example, wherein you need dedicated hardware to continuously run weather simulations. Similarly, you need people from the aviation industry, you need people from the automotive industry who do all those aerodynamic kind of simulations, airflow, wind tunnel simulations. Those people will typically fall under the HPC category.
I also remember you mentioning some government labs having this HPC infrastructure, or some private labs semi-funded by government.
Both. It's a mix of both. It's a mix of both. You can actually rent out hardware. So if you are, let's say, a small scale company who does automotive work, and you cannot probably afford an entire HPC system, you can probably rent it out from us.
Okay. And when we talk about HPC, is it always a big sized cluster, or it can also be an individual HPC machine?
Most of the cases not. Typically, HPC would at least require you to have a 4 or 8 node cluster.
Okay.
If you want to do some real world simulation. For test purposes, for debugging, for benchmarking, a single machine or a single cluster is good enough. But if it's a real size workload, typically you have to go for something bigger.
Right. And so far, if you could just give us some examples of work that we have done in this domain, or something that is lined up for us.
Okay. In that regards, like I said, alluded to, weather forecasting, we have done benchmarking on the WRF model, which is from the UK Meteorological Department. We have done automotive simulations on a free and open source available workload, OpenFOAM, and that we do then publish.
Nice. So we can also help these labs select suitable hardware by running some benchmarks and doing the comparative analysis.
Yes.
When they buy any new HPC hardware, right?
Yes. So typically buying HPC hardware is not go to a store and buy HPC hardware.
Of course, it's not a commodity.
Yeah. Typically, it's a 2-year cycle in most cases. So what you want to buy now will happen after 2 years.
Right.
So it's a 2-year RFP cycle. So there is a request for proposal, and what they will publish, or these institutes or labs will publish, is so far we have XYZ machines. This is our score on certain benchmarks. And for our next upgrade, what we are looking for is these benchmarks giving us Y score instead of X. Then it comes down to testing out individual machines on those. Like what sort of machine can give us that when we scale it up to that cluster size. That we do definitely help. Nice. We do total cost of ownership analysis.
Okay.
So we do power analysis because sometimes even that is a strict requirement. Like you cannot spend X amount of electricity, or you cannot go beyond a certain amount. In that case, maybe the cost doesn't matter. Power saving is a big. So we do that also. And that process is typically a longish process, 6 months, 8 months process.
Nice.
When there's a lot of back and forth, they'll give us the requirements, we'll run those benchmarks, we'll see what the original hardware that they have performs and what they're expecting.
Right.
Then we'll go test it out and see if it's possible. If yes, well and good. If no, then we'll suggest some other hardware.
Got it.